In our line of work, repairing things is inevitable. You're going to eventually come across something that you have to repair, whether it's something of yours, something in production, and that's in all types of industries. But there's a question that always needs to be asked is, at what point do I stop diagnosing whatever I'm working on and just repair it? So that could be working on electronics, that could be working on, everything from furniture, vehicles, even houses. At what point do I stop trying to figure out what the problem is? What point have I determined enough and I just need to repair the thing? It's not worth going any deeper. I just need to replace this whole set of components. I just need to rebuild whatever part of the house that is broken. I just need to just go ahead and replace this component on a car, or I just need to just go ahead and replace this board or this module in it. At what point do you say, I'm going to finish diagnosing, it's too expensive, it's taking too much time, and I'm just going to repair this whole section? So that's what we're going to talk about in today's video, using this as an example of what I did to repair this board. Let's discuss what point diagnostics is more time-consuming, is expensive, and is not worth it versus just repairing what you have figured out so far. This is a 555 timer based Pinewood Derby track module. So it has 4 different lanes. It's all just these 7 segment display drivers in the 555 timer that then clocks those at some millisecond interval. And then here is the switch module, if you can see that at the top. The problem that was happening with this was when it wasn't doing anything. The displays were lighting up, but when you hit the start switch and things, it wouldn't do anything. So how I repaired it was I checked all my voltages, right? You have a 9-volt input voltage, and then that goes here to just a regular ALM 5-volt regulator. And then since those were working, then I checked my switches, and I made sure my switches were working properly and sending signal to this logic section. And so then I started tracing the lines coming from the switches to the logic section. So let's zoom in on this section and I'll show you what I did. So I started tracing the switch inputs to these logic chips. Some of them are flip-flops, some of them are different things. An AND gate, I think this is a NAND gate maybe, I don't quite remember. And then here's the 555 timer chip, and then here's another 74 series logic chip. And I started tracing the signals down through here, and they split off into 2 or 3 different paths. The reset button and the start button does, and it goes through and then comes out here and then goes out through here. And I realized something when I'm troubleshooting this, that the start signal was getting in, but it wasn't getting out of part of these chips. And so I started trying to trace back, and it was taking a lot of time to try to figure out where the signal was going in these chips. So I decided just to replace all these chips, and I looked it up, and it was $13 to replace all 5 of these chips right here, $13. And I realized, why would I continue to try to figure out which chip is not handling the signal properly if I can just replace the whole section for $13? So I realized that diagnosing this circuit was not worth it anymore if I could just replace this whole section for just a couple of dollars per chip, instead of spending another hour or 2 trying to figure out which chip it was that was not outputting correctly. And after replacing all those chips, the module works. So if I flip the start switch here, it's kind of hard to see on camera, but all of the timers are going, and then as a car goes across each one of these sensors, it will trip one of these. And then this is a dual 555 timer. The second leg, I think, blinks this. I think that's what the second leg of this is for. One's for the timing of the 7-segment display chips, and then one is for the blink. And then you hit the reset button, and there you go. Everything is right. But I repaired this after just deciding to replace these chips. And I bought 3 different sets of chips for $13. So I didn't just buy a whole set, but 3 different sets. So let's go back to the workbench and talk about what we did. So those are my thoughts or my methods. If I can just replace a section of components that I know this section is bad, or something in this section is bad, and I can just replace it for a few dollars, I'm going to do that without drilling down to exactly which pin on which IC has went bad. That's what I'm going to do, because I don't want to spend all that time diagnosing it, because it's cheaper just to replace it. Now, if you're in a production environment, you kind of want to know that, because you want to know if you need to update your design, what's causing these early life failures, those kind of things. But when I'm just repairing something like this for a friend, and I can just replace the whole set of components for $13 and then have 2 more sets for that $13, and so, you know, this set will probably last 10 or 15 years, and he can just throw a whole new set in if we're all still alive 15 years from now. I'm going to do that. That is my method. Now, some people, some technicians, some engineers, they want to know exactly what failed in this board from the 1980s. I want to know which pin failed. I don't really care. And that's something you have to decide for yourself. At what point do you say, I don't really care which one of these logic chips has died, or which section in these logic chips has died, because I can replace the whole section of logic chips for a few dollars. So you have to decide whether you want that to be your attitude. You want to drill down to the nth degree and only replace the single chip. But that's my method. If I know that I can replace this module, if I know I can replace this component, if I know I can replace this whole section of the circuit for a few dollars, and it's easy to do, and I know that this section is what is broken, then that's what I'm going to do. That is my method. Hopefully that gave you a little bit of insight, maybe a little bit of wisdom of what to do. Sometimes it's not worth finishing diagnosing all the way to the bottom, all the way to the nth degree, and it's easier just to repair the whole section. You know this section is bad, just repair the whole thing. Put a new set of chips on it, put a new set of caps on it, whatever you need to do, and just repair it. It's just easier to do. So I hope everybody liked this video. Kind of a different video than what I normally do, but it was just what I was working on, so I thought I'd show you this week what I've been doing. So please like and share the video. Please subscribe to the channel for more content like this, and I guess I'll see everyone whenever I decide to make a new video.